just want the variable on one side. Then we can look to solve. Let's jump into our examples and see what this looks like. Starting with number 1, where we have 5x minus 4 equals 2x plus 11. So we need to figure out what x equals. The first thing that we need to do, we need to get the variable so it's just on one side of the equation. Now we can do this either way. We can get the variable on the left or on the right. Either way will work, but my suggestion, look to avoid negatives as far as the variable goes. And we can do that by getting rid of the one with the coefficient that is smaller in value. So the number in front of the variable that is smaller in value. That's going to be 2x for number 1. So let's get the variable on the left side only here. That means we need to undo or get rid of the 2x on the right side. That's a positive 2x. So the inverse operation would be to subtract 2x. So let's subtract 2x from the right side of the equation. Whatever we do to one side of the equation, we must do to the other. So subtract 2x from the left side as well. Now on the right side of the equation, we have positive 2x and then minus 2x. So these two x's cancel each other out, and we are left with 11 on the right side of the equation. And then on the left side of the equation, we have 5x minus 2x. So we can subtract those like terms. That's going to give us 3x. And then we can bring down the rest of the left side here, so minus 4. So now we have 3x minus 4 equals 11. And that variable is on one side. We have it on the left side only now. And now we can solve. So we need to isolate that variable of x. And remember, we do that by using inverse operations. And we're going to go in the reverse order of operations. So we need to undo the subtraction first. What's the inverse operation of subtraction? Well, addition. So let's add 4 to the left side of the equation. Whatever we do to one side, we must do to the other. So add 4 to the right side as well. Now on the left side, we are subtracting 4 and adding 4. So these 4's cancel each other out. We now have 3x equals, and then on the right side, 11 plus 4 gives us 15. So we have 3x equals 15. 3 times x equals 15. So we need to isolate that variable of x. So what's the inverse operation of multiplication? Well, division. So divide the left side by 3. Whatever we do to one side of the equation, we must do to the other. So divide the right side by 3 as well. Now on the left side, we are multiplying by 3 and dividing by 3. So these 3's cancel each other out. X is now isolated. So we have x equals, and then on the right side, 15 divided by 3 gives us 5. So x equals 5. That's our solution. Now let's check that solution by plugging it in for x and seeing if it works. So let's come to the side here. We have 5 times 5 minus 4 equals 2 times 5 plus 11. Let's work through the left side first. So we have 5 times 5, which is 25. 25 minus 4 gives us 21. Now on the right side, we have 2 times 5, which is 10. And 10 plus 11 is 21 as well. So both sides equal 21. We are correct. X equals 5. Let's move on to number 2, where we have 3y plus 8 equals 10y minus 6. So we have that variable of y on both sides. We need to get the variable on one side, and then we can look to solve. We need to decide which side of the equation we want the variable on. Like I mentioned earlier, either way will work, but my suggestion, look to avoid negatives as far as the variable goes. And we can do that by getting rid of the 1 with the coefficient that is smaller in value. We have a 3 in front of the variable and a 10 in front of the variable. 3 is smaller in value, so let's get rid of the 3y. Now that's a positive 3y, so the inverse operation, subtract. So let's subtract 3y from the left side. Whatever we do to one side, we must do to the other. So subtract 3y from the right side as well. On the left side of the equation, we have a positive 3y minus 3y. So these 3y's cancel each other out. We now have 8 equals, and then on the right side, we can subtract those like terms. So 10y minus 3y gives us 7y, and then we can bring down the rest of the right side, so minus 6. And now we have 8 on the left side of the equation equals 7y minus 6, which is on the right side of the equation. So we need to isolate that variable of y. So we need to undo the subtraction first. The inverse operation is addition, so add 6 to the right side of the equation. That means we need to add 6 to the left side as well. Now on the right side of the equation, we are subtracting 6 and adding 6, so these 6's cancel each other out. And now we have 7y equals, and then on the left side, 8 plus 6 gives us 14. So now we have 7y on the right side of the equation equals 14 on the left side. So we have 7 times y equals 14. We need the inverse operation. The inverse operation of multiplication is division, so divide the right side by 7. That means we need to divide the left side by 7 as well. Now on the right side, we are multiplying by 7 and dividing by 7, so these 7's cancel each other out. Y is now isolated, so we have y equals, and then on the left side, 14 divided by 7 gives us 2. So y equals 2. That's our solution. Now let's check that by plugging it in for y and seeing if it works. So we have 3 times 2 plus 8 equals 10 times 2 minus 6. Let's start with the left side. So we have 3 times 2, start with multiplication. That gives us 6. And then we have 6 plus 8, which is 14. Now for the right side, so let's start with multiplication. 10 times 2 gives us 20. And then we have 20 minus 6, which is 14. So we get 14 on both sides. We are correct. Y equals 2. So there you have it. There's an intro to solving equations with variables on both sides. I hope that helped.